It is a violation of the National Electrical Code to run video cabling and power wiring for cameras in the same conduit, unless specific conditions are met. Article 725.110. D states that low-voltage cables run in the same raceway or enclosure with power conductors shall be CL2 or CL3. Article 725.130. It states that power-limited circuit conductors shall not be placed in the same raceway cable or enclosure with other circuit conductors unless the conductors are separated by a solid barrier. If you need to run video cabling and power wiring in the same conduit, the following low-voltage cable types are acceptable. Firstly, CL2 cable is listed for installation in concealed spaces, such as walls and ceilings. Secondly, CL3 cable is listed for installation in concealed spaces and exposed areas, such as surface-mounted conduit. If non-CL2 or CL3 cable is used, a solid barrier must be installed in the conduit to separate the power wiring from the video cabling. The conduit must be sized appropriately for the number and type of cables being installed. The cables must be securely supported and protected from physical damage. Proper wire connectors and terminations must be used. The installation must be inspected by a qualified electrician to ensure compliance with the NEC. Let's delve deeper into the specifics of these requirements. Firstly, concerning Article 725.110. D. It's crucial to understand the intent behind requiring CL2 or CL3 rated cables when sharing a raceway with power conductors. These cable types are specifically designed and tested to meet stringent safety standards, particularly in relation to their insulation properties and fire resistance. They are constructed to minimize the risk of electrical faults and the potential for fire propagation, which are critical considerations when combining low voltage and power circuits in a confined space. The use of CL2 or CL3 cables provides an added layer of protection against hazards such as short circuits, ground faults, and overheating, which could otherwise compromise the integrity of the entire electrical system and pose a significant safety risk to occupants. Secondly, let's examine Article 725.130. A, which mandates the separation of power-limited circuit conductors from other circuit conductors within the same raceway cable or enclosure unless a solid barrier is implemented. This requirement is rooted in the principle of preventing interference and potential hazards that can arise from the interaction of different voltage levels and circuit types. Power-limited circuits, by their nature, operate at lower voltage and current levels compared to power circuits, and they are typically more susceptible to electromagnetic interference and voltage fluctuations. Placing these circuits in close proximity without proper separation can lead to signal degradation, data corruption, and even equipment malfunction. The solid barrier serves as a physical shield that isolates the power-limited conductors from the influence of the power conductors, effectively minimizing the risk of interference and ensuring the reliable operation of both circuit types. Furthermore, the separation requirement helps to prevent accidental contact between conductors of different voltage levels, which could result in electrical shock or equipment damage. The selection of appropriate cable types, such as CL2 or CL3, is paramount when adhering to NEC guidelines for mixed voltage installations. CL2 cables are specifically designed for use in Class 2 circuits, which are characterized by their limited power output and inherent safety features. These cables typically have a voltage rating of 150 volts or less and a current rating of 5 amps or less, making them suitable for low-voltage applications such as security systems, audio systems, and control circuits. CL3 cables, on the other hand, are intended for use in Class 3 circuits, which have slightly higher voltage and current limits compared to Class 2 circuits. CL3 cables typically have a voltage rating of 300 volts or less and a current rating of 1000 volt-amps or less, making them suitable for applications such as fire alarm systems, public address systems, and remote control circuits. Both CL2 and CL3 cables are subjected to rigorous testing and certification processes to ensure their compliance with safety standards and their ability to withstand the environmental conditions and electrical stresses encountered in typical installations. These cables are constructed with high-quality insulation materials that provide excellent electrical properties and resistance to abrasion, moisture, and chemical exposure. They are also designed to minimize the emission of electromagnetic interference and to prevent the propagation of fire in the event of an electrical fault. When choosing between CL2 and CL3 cables, it's important to consider the specific requirements of the circuit and the intended application. Factors such as voltage and current levels, environmental conditions, and regulatory requirements should all be taken into account to ensure that the selected cable type is appropriate for the task. In situations where non-CL2 or CL3 cables are used, the installation of a solid barrier becomes mandatory to maintain compliance with the NEC. The solid barrier serves as a physical separation between the power wiring and the video cabling, preventing direct contact and minimizing the risk of electrical interference or damage. The barrier must be constructed of a non-conductive material that is capable of withstanding the environmental conditions and mechanical stresses encountered in the conduit. Common materials used for barriers include plastic, rubber, and fiberglass. The barrier must be securely installed within the conduit, ensuring that it effectively isolates the power wiring from the video cabling throughout the entire length of the run. The barrier should also be designed to prevent the accumulation of moisture or debris within the conduit, which could compromise the integrity of the electrical system. In addition to the cable type and separation requirements, there are several other important considerations to keep in mind when installing video and power cabling in the same conduit. Firstly, the conduit must be sized appropriately for the number and type of cables being installed. Overcrowding the conduit can lead to overheating, insulation damage, and difficulty in pulling the cables through the raceway. The NEC provides guidelines for conduit fill, which specify the maximum allowable percentage of the conduit's cross-sectional area that can be occupied by cables. Secondly, the cables must be securely supported and protected from physical damage. This can be achieved by using cable ties, straps, or other suitable supports to secure the cables to the conduit at regular intervals. The cable should also be protected from sharp edges, abrasion, and other potential hazards that could damage the insulation. Thirdly, proper wire connectors and terminations must be used to ensure reliable electrical connections and to prevent loose or corroded connections, which could lead to overheating or arcing. All wire connectors and terminations must be listed and labeled for the intended application and must be installed in accordance with the manufacturer's instructions. Finally, the installation must be inspected by a qualified electrician to ensure compliance with the NEC and other applicable codes and standards. The electrician should verify that the cables are properly installed, supported, and terminated, and that all safety requirements are met. The electrician should also perform electrical tests to ensure that the circuits are functioning correctly and that there are no potential hazards. Failure to comply with the NEC can result in fines, penalties, and even legal action. It can also jeopardize the safety of occupants and property. Therefore, it's essential to follow all applicable codes and standards when installing video and power cabling in the same conduit. By understanding the NEC requirements and implementing appropriate safety measures, you can ensure a safe and reliable electrical system. The NEC, or National Electrical Code, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is developed and maintained by the National Fire Protection Association, or NFPA, and is widely adopted by state and local jurisdictions as the basis for their electrical codes. The NEC covers a wide range of topics related to electrical safety, including wiring methods, overcurrent protection, grounding, and equipment installation. It is designed to protect people and property from electrical hazards such as shock, fire, and explosion. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and to address emerging safety concerns. The latest edition of the NEC is typically adopted by state and local jurisdictions within a year or two of its publication. It is important for electricians, contractors, and other electrical professionals to stay up to date with the latest edition of the NEC and to understand its requirements. The NEC is a complex and detailed document, and it can be challenging to interpret and apply its provisions in specific situations. Therefore, it is often necessary to consult with a qualified electrical inspector or engineer to ensure compliance with the code. The NEC is not intended to be a design manual, but it provides a framework for safe and reliable electrical installations. It is the responsibility of the electrical designer to select appropriate materials and equipment and to design the electrical system in accordance with the NEC and other applicable codes and standards. The NEC is a living document that is constantly evolving to address new challenges and to improve electrical safety. By staying informed about the latest changes and updates to the NEC, electrical professionals can help to ensure that their installations are safe, reliable, and compliant with all applicable regulations. The use of proper wiring methods is crucial for maintaining electrical safety and preventing hazards. Wiring methods refer to the techniques and materials used to install electrical conductors in a building or structure. The NEC specifies a variety of wiring methods that are suitable for different applications and environments. Some of the most common wiring methods include rigid metal conduit, electrical metallic tubing, flexible metal conduit, non-metallic conduit, and cable wiring. Each wiring method has its own advantages and disadvantages in terms of cost, ease of installation, and suitability for specific applications. Rigid metal conduit, or RMC, is a heavy-walled metallic raceway that provides excellent mechanical protection and is suitable for use in harsh environments. RMC is typically made of steel or aluminum and is available in a variety of sizes and lengths. Electrical metallic tubing, or EMS, is a lightweight metallic raceway that is easier to install than RMC but provides less mechanical protection. EMT is typically made of steel or aluminum and is available in a variety of sizes and lengths. Flexible metal conduit, or FMC, is a flexible metallic raceway that is used to provide flexibility and movement in electrical installations. FMC is typically made of steel or aluminum and is available in a variety of sizes and lengths. Non-metallic conduit, or PVC, is a lightweight non-metallic raceway that is resistant to corrosion and is suitable for use in wet or damp environments. PVC is typically made of polyvinyl chloride and is available in a variety of sizes and lengths. Cable wiring refers to the use of insulated conductors that are bundled together to form a cable. Cable wiring is available in a variety of types, including non-metallic sheared cable, armored cable, and metal-clad cable. The selection of the appropriate wiring method depends on a number of factors, including the type of building or structure, the environmental conditions, the electrical load, and the budget. It is important to consult with a qualified electrician or engineer to determine the most appropriate wiring method for a specific application. Proper overcurrent protection is essential for preventing electrical fires and protecting electrical equipment from damage. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of electricity in the event of an overload or short circuit. Circuit breakers are resettable devices that can be tripped manually or automatically. Fuses are one-time use devices that must be replaced after they have blown. The NEC specifies the size and type of overcurrent protection devices that are required for different circuits and equipment. The size of the overcurrent protection device must be coordinated with the ampacity of the conductors and the rating of the equipment. The type of overcurrent protection device must be appropriate for the application. For example, time delay fuses are often used to protect motors because they can withstand temporary overloads without tripping. Grounding is an important safety measure that helps to protect people from electrical shock. Grounding provides a low impedance path for fault current to flow back to the source, which causes the overcurrent protection device to trip and energize the circuit. The NEC specifies the grounding requirements for different types of electrical systems and equipment. The grounding system must be properly installed and maintained to ensure its effectiveness. Equipment installation is another important aspect of electrical safety. Electrical equipment must be installed in accordance with the manufacturer's instructions and the requirements of the NEC. The equipment must be properly supported, ventilated, and protected from physical damage. The equipment must also be properly grounded. Regular electrical inspections are essential for identifying potential hazards and ensuring that the electrical system is safe and reliable. Electrical inspection should be performed by a qualified electrical inspector. The inspector will check the wiring, overcurrent protection, grounding, and equipment installation to ensure that they comply with the NEC and other applicable codes and standards. Any deficiencies that are identified during the inspection should be corrected promptly. By following these guidelines, you can help to ensure that your electrical system is safe and reliable. Always consult with a qualified electrician or engineer for assistance with electrical installations and repairs.